Uh, Good day, everyone. There's a request, yeah, general solutions. So I deemed it necessary that I do this recording based on the general solutions. So as much as we did this part in grade 11, now we also need to do it in grade 12, because in grade 12, if we check on trigonometry, we've got compound angles. We also have double angles. So hence the necessity for us to do general solutions, because in grade 12, our general solutions, to some extent, they will include either compound angles or the double angles. So now, what is the meaning of the term general solutions? It means that they give you a question that has got more solutions to it. And then now, I want us to work this using algebraic method. Algebraic method, which in most cases we call solve for x. So if we are able to use the algebraic method, which is solve for x, to find the general solutions, it seems that when we do algebraic expressions or algebraic equations, it will be very much easier, because you'll get the practice here, you will also get the practice here. So when you have got the algebraic equations to solve, it means that we'll also be able to solve the general solutions. So now, why the need for us to do this? Now, re dira solve for x. Question is, how many solutions of our equations do we have in terms of x? Say, for example, we have x to the power of 4. X to the power of 4 as our degree, it tells us that with whatever equation, you have how many solutions? 4 solutions. And then if we have x to the power of 3, it means that we have 3 solutions. And then if I'm working on x to the power of 2, it means that I've got 2 solutions. And if my x has got the degree of 1, it means that I've got 1 solution. So the very same way that we are working with the algebraic equations in terms of solving for x, the number of the value of your degree tells you exactly how many solutions you need for that particular equation. So, but with the general solution, what we mean is that we are going to check the degree in which, or the degree of the solutions that we, or that the solutions that we need. If you find that you are given, say for example, let's call this our first activity. And then they say find the general solutions of 4 plus 7 cos theta plus cos 2 theta equal to 0. So this one, if we check, is an equation because of the equal sign. So since we have the equation, it means that now we are going to check on this equation. What is our dominating ratio? Sorry, not ratio, But what is our dominating ratio? So if we check, our equation dominates with the ratio of cos. So it means that our dominating ratio is cos theta. Then, if the dominating ratio is cos theta, the second question is, do we have the compound angles? If you check here, you've got cos 2 theta. But what is cos 2 theta? Is cos 2 theta a compound angle, or is cos 2 theta a double angle? So we need to check whether the compound angle and the double angles exist here. Which one between the two exists? We can spot that we actually have the double angles than the compound angle. Now, if we have a double angle, which one of the ratio here tells us the double angle is cos 2 theta? So this means that as much as we said that the dominating ratio is cos, it means that we also need to represent our double angle as cos. So now, how do we represent cos 2 theta as cos? Cos 2 theta has got three solutions, which is cos squared theta minus sine squared theta. We can also write cos 2 theta as 2 cos squared theta minus 1. We can also write cos 2 theta as 1 minus 2 sine squared theta. So we need to write our ratio as cos, not as sine, because we don't need sine here. We only need cos. So which one of the three will give us cos alone? We can see that the second one will give us 2 cos squared theta minus 1. So in place of cos 2 theta, we are going to write 2 cos squared theta minus 1. Therefore, we have 4 plus 7 cos theta plus 2 cos squared theta minus 1 equal to 0. If we arrange this according to the ascending order of our degree, sorry, not ascending, but descending order of the degree, it means that we have 2 cos squared theta plus 7 cos theta. Then what is 4 minus 1? Then we have positive 3 equal to 0. So now that we have this, we can now make a statement. So if you check, we have something like a quadratic equation. We have something called quadratic equation, in which it's squared, 1, and constant, which means that we have got A, B, and C. So you can say that instead of working this as cos, you can say solve for cos theta. So you remember that we used to say solve for x. So this means that if we say let cos theta equal to x, it means that from the general equation for quadratic formula, we can say if we know it as x equals to minus b plus minus b squared minus 4ac all over 2a. What we can do is that where we see x, we can simply substitute it by cos in this equation. Where do we see x. We see x here. So it means that we can, in place of x, we can write it as cos. Therefore, we can say cos x, sorry, not cos x, cos theta is equals to minus, what is the value of b? The value of b is 7, plus minus, then we have 7 squared minus 4 into 2 into 3. Then we square everything, all divided by 2 into 2. So, but here we've got cos theta equals to negative 1 over 2, or cos theta equals to, let's say, negative 3, which in this case, theta is undefined. Now, we can now solve this going forward. So if you say theta is equals to arc cos of negative 1 over 2, you find that the value of theta here negative 1 over, then our first answer for this is 120 degrees. Then if we represent this on a Cartesian plane, we first press our theta as positive, not as negative. So it means that we can also write, we can start by saying theta is equals to arc cos of 1 over 2. Then we ignore this negative. Then it says that the value of theta is equals to 60 degrees. Now, we're saying that 60 degrees is in the first quadrant, second quadrant, third quadrant, and then fourth quadrant. So, but the question is, if we have 60 here, in the second quadrant, we also need to draw the same angle, which in this case, from here to there, it will be 180 degrees minus the acute angle, which is 60. Then we will get an angle which is 120 degrees. Then we also do the very same thing this side. So if we are moving from here going around until here, it means that we already passed 180. So it means that to find the angle here, we're going to say 180 degrees plus the smallest acute angle, which is this. Then the solution will be 240 degrees. So if I want to know this angle from this side, it means that I must go again until I reach that point. Then it means that I'm going to say, here we've got 360, but when we go this direction, we subtract, and when we go that direction, we add. So if I say 360 degrees minus the smallest acute angle, which is 360 minus the smallest acute angle that we find, the answer is 300 degrees. So now, once it's like this, we are coming to check in which quadrant do we find cos as negative, or in which quadrant do we find the cos of an angle as negative. So according to CAST, it shows that all ratios in the first quadrant are positive. In the second quadrant, only psi is positive in the second quadrant. And then here only tan is positive in the third quadrant. And in the fourth quadrant, only cos is positive. So in which quadrants do we find cos as negative? We find cos as negative in the second quadrant and in the third quadrant. So this means that this angle that we are looking for must be in the second quadrant and in the third quadrant. So we said that we found 120. 120, we can only get it because here we have said negative. So we can say plus 180 degrees. So the answer will be 120. And we can say also cos theta is equals to, then from here we say, okay, because we are saying 180 minus, remember minus, here we add, here this side we are going to say 120 minus, but when we go this side we are going to say 180 plus. So it means that we have cos negative 1, which is the same as positive 120 degrees. Again, this is what it is. But also in this side, we're going to say this is the same as cos. Sorry, our theta is the same as 180 degrees plus the smallest acute angle that we found, which is 240 degrees. So the next angle of theta will be 240. So how do we write our solutions in this case? Theta is equals to 120 degrees plus k multiplied by 360 degrees. And theta is equals to 240 degrees plus k multiplied by 360 degrees. So these are our solutions. Thank you.